Welcome to the screencast-o-matic video version of quadratic functions in factored form, the notes, and this is part 2 of the notes. When we stopped in part 1, we had graphed that lovely parabola, although that's not quite so lovely the way I drew it. One thing I'd like to point out to you, actually I'm going to erase that, believe it or not, and draw that a little more carefully, because what we learned the last time is that parabolas always flare out. So if you draw a parabola for me, be sure it flares out and does not flare back in, or does not curve back in, because then I will count you wrong. Okay, so let's continue on with example 3. And if I tell you that the x-intercepts of a parabola are at 3 and 11, so we don't know whether this thing is pointing up or down. We don't know a whole lot about this parabola, but we do know what the x-coordinates are, or the x-intercepts are. And so if I give you a 3 on a number line, and I give you an 11 on a number line, how do you find that point that's halfway in between? Well, you guys probably vaguely remember from previous classes that to find a point halfway in between, you can add these two values together and divide by 2. So we're going to add 3 plus 11, which is 14, and then divide by 2. So 14 over 2 is 7. So the coordinate of that point in between is 7. So let's kind of put this officially, and we're going to look at the factored form of a quadratic equation. And this is something that is now a little bit familiar to you guys. We have an A, which would be the GCF. I'm not going to muddy the water here. So A would be the GCF, and R1 is one root, and R2 is the other root. So the x-intercepts here, for x-intercept, y is equal to 0. I have to think about that consciously every time. So both of these, the y is equal to 0, and the value of one is R1, and the value of the other is R2. So therefore the x-coordinate of the vertex is what we did up here. We're going to add the two together and divide by 2. So you can think of this as taking the average of those 2 points. Okay, let's use this information as we explore factored form again. Okay, so we're going to do some practice, and it would really be coolio if you would shut off your computer right now, or turn me off, put me on pause, and see if you can figure these things out by yourself. I'm going to act as if you've already done that, and I'm going to work through these problems. So, for the y-intercept, x has to be equal to 0. So y is 1/4 times 0 times 0 minus 4. And anything, since one of these factors is 0, that's going to be 0. So the y-intercept is 0, 0. Now that's going to come into play in a second. You're going to see that makes this situation a little bit interesting. Okay, I'm going to come here and I'm going to do the x-intercepts, which means that y is equal to 0. So 0 is equal to 1/4 x minus 4. Did I do that right? Okay, so the x-intercepts are where y is equal to 0, and you have either x is equal to 0 or x minus 4 is equal to 0. So x is 0 or x is 4. And our two x-intercepts are where y is equal to 0. And I have 0, 0 and 4, 0. So 0, 0, look at that, is already a y-intercept. It's also an x-intercept too. And the other x-intercept is here. So this is going to be interesting because it's going to cause us to have to do a little finagling to get 5 points, which is what we need to plot. But we do have the ability to figure out where the vertex is. And that vertex is going to be halfway between the two roots. So we can say vertex, x at the vertex is equal to r1 plus r2 over 2, which is equal to 0 plus 4 over 2, which is equal to 2. So we know, which was pretty obvious anyway, but now we have put a quantity on the fact that the line of symmetry is at x is equal to 2. Now the coordinates of the vertex. We know that it's going to be along this line. So we can go ahead and plug the vertex in here. So so at x is equal to 2, y is equal to 1/4 times 2 times 2 minus 4. And that's going to be, this is a 4. So 2 times negative 2 divided by 4 is negative 1. So that is going to be the coordinate of the vertex. This is going to be a really wide parabola that faces up. And that wideness actually comes from A, or the GCF. Okay, so to get a couple of more points, we're going to have to choose a couple of, or one more point, and we're just going to use it to compute the y, and then we're going to do its symmetric point. So I'm actually going to choose, since these are 2 apart, I'm going to choose, let's say positive 6, and let's see what we get. You can choose really any point, but positive 6 I suspect is going to give us an integer, and that makes it nice to plot. So y is equal to 1/4 times 6 times 6 minus 4. And so y is equal to, that's a 6, that's a 2, so 12 over 4 is 3. So we have a 3 over here. And then we can go over, since this is 1, 2, 3, 4 away from the line of symmetry, we can just follow that horizontal coordinate 1, 2, 3, 4 to get our 5th point. So our 4th point is going to be at 6, 3, and our 5th point is going to be negative 2, 3. So there is our lovely wide parabola that is so difficult to draw on my slate. And you notice that it's flaring out. It's not curling back in on itself, because that's bad. Okay, let's go on to the next example. And you can probably read right here, what are the two x-intercepts? Is either x is equal to negative 3 or x is equal to, so positive 3 and negative 3 are our two roots. There they are. So, you know, you set that factor equal to 0 and you set that factor equal to 0 to get 3 and negative 3. Okay, our line of symmetry is halfway between. So 3 minus 3, or plus a negative 3 over 2, and that is 0. So x at the line of symmetry is 0. So our line of symmetry is here. So we can plug in to find the y of the y. So the vertex will be along this line. Vertex along x is equal to 0. So y at x is equal to 0 is negative 2/9. 0 minus 3, 0 plus 3. So that together is negative 3 times 3 is a positive, or a negative 9 times 2/9 is a positive 2. So there is our line of symmetry, and our vertex is going to be x is 0, y is 2. Okay, so once again we have a problem where the our y-intercept is one of the points that's crucial, which is the vertex. So it's along the line of symmetry. So I'm just going to pick another point to compute another value and then get its mirror across the line of symmetry. So check this out. So these are 3 away. And if I'm going to get a point that has an integer, I'm going to go out an equal distance to 6. So I'm just going to choose, you can choose any value, but I'm going to choose x is equal to 6 because I know I'm going to get a pretty number. So y at x is equal to 6 is negative 2/9 times 6 minus 3 and 6 plus 3. And so that's a 3, that's a 9. So that 9 and that 9 cancel out. And I'm going to encourage you to do this systematically for yourself. But that's a 9, that's a 9. And so negative 2 times a positive 3 is a negative 6. So that's going to come down here. And let's see. So 1, 2, 3, 4, 5, 6 away from the vertex or from the line of symmetry. So we can go 1, 2, 3, 4, 5, 6 to find that 5th point. And then we can connect the dots. Now, that's not a good connection, but there it is. And we have our parabola. Okay, here is just a list of the things that we have been doing so that you have something to refer back to when you're working these problems. And tune back into the 3rd video, and I'll work a couple of more very important problems that you'll find on your homework.